Have you ever wondered why the sun is so hot? What is its energy source? The sun is made of hydrogen. Hydrogen burns, right? Well, there's no oxygen in space, so it couldn't be a fire. So what is it? The sun is extremely large. So large, in fact, that at its center there is enough pressure to force the nuclei of hydrogen atoms together, creating heavier elements. This process generates energy from the binding energy of the atoms. An atom of hydrogen 1 has a mass of 1.0078 atomic masses, so as follows, 4 atoms of hydrogen 1 have a mass of 4.0313 atomic masses. But an atom of helium 4 has a mass of 4.0026 atomic masses. That means that 0.0287 atomic masses are lost. This is where the energy in fusion comes from, the lost mass. Is there a way to harness this energy for ourselves on Earth? Yes, but it's tricky. First off, we don't have the mass of the sun at our disposal for high-pressure fusion on Earth. As a result, to achieve fusion on Earth, an extremely high temperature is required, a temperature much hotter than the sun. Also, no material can contain the hot hydrogen and helium. They would melt and vaporize. The material is so hot that all of the electrons have left the atoms, and the nuclei have become positively charged. That means that magnetic fields could be used to corral the material. Nuclear fusion is very safe. For nuclear fission, a meltdown means molten and radioactive material getting everywhere. For fusion, a meltdown means the gas dispersing and cooling down almost instantly. Fusion on Earth is different than on the Sun. While the Sun uses the proton-proton chain for hydrogen fusion, this process requires extremely high temperatures, or pressures, and is fairly slow. The reason the Sun hasn't burnt out yet is that parts of the proton-proton chain can take millions of years. On Earth, we would use a different process that burns quicker and with less energy input. It involves fusing deuterium with either tritium or helium-3. Tritium is radioactive, so it decays over time. As a result, tritium is extremely rare and expensive. A better alternative might be helium-3. Helium-3 isn't very common on Earth, but on the Moon, the billions of years of radiation from the Sun has enriched the regolith with helium-3. Therefore, helium-3 is the better option. Also, it gives us another reason to set up bases on the Moon. In conclusion, fusion energy might become the cheap, clean energy of the future. It might bring us back to the Moon and progress humanity into space with a good energy source.